Most of you are in WebAssign, and that's cool. But for anybody who's like, nah, I'm good, like I'm ready to move on. Once again, there is a Jamboard. Once again, there is a Jamboard that you guys can be getting set up for today, which is section 3.6. However, there are a few other things as well that you can do before I ever start talking about section 3.6. I wouldn't go to con practice, even though it's good. I wouldn't go to the practice itself, even though there is a practice that's been assigned to you. This is the one homework. You got it? This is the con practice is the one homework due Monday, due chapel day. Okay? The other homework is due, oh sorry, not Tuesday. You guys have class Wednesday. The actual like WebAssign homework isn't due until Wednesday. So we're starting 3.6 today, but I'm guessing we're going to need to do some more examples on Monday. So the only homework due Monday, I have it 3:30 in case you guys want to go over anything. It's only 4 problems. But are you hearing me? Only 4 problems I'm making be the only homework due on Monday. Like these problems can take time. Does that make sense? So the con practice due Monday. Now, whenever you go into Khan Academy and go to one of those practice sets, what was technically before that practice set on the website? Have you guys ever noticed? Okay. Yeah, the lesson. Like he has all these videos that prepare anyone for those practice problems. So one reason I want this to be the 4 problems, only 4 problems due, is if you're like, I have no clue, you have 2 options. Can you guys see my wording real quick? If you don't know what to do, you have 2 options. One is, go back in Khan's videos, right? That could help because he taught, he showed, he did examples to get you ready for his own practice. And he usually does the calculus. You can tell it's him because of his voice. He does have other people helping, of course. But I'm also attaching, so this is one of those things, if you're like, hey, I'm totally good, you could check out the beginning of the Organic Chemistry Tutors videos if you have headphones and you don't need this WebAssign practice. Before just getting into the next WebAssign, I wouldn't do that. I would either go check out like a video of Khan or maybe like a video of the Organic Chemistry Tutor. This one is like his full lesson, but he's starting to, he's done a lot of work. He's an excellent tutor, just for you guys to know, this guy right here, as far as chemistry, college sciences, college math, he has a lot of videos online. But I think with all the work he's done, he needs to be getting paid for it. So I can't promise that whole video is there, but I did go through it, and I think this is one, because he's starting to be like, hey, I've shown you some, but if you want more, you have to, I forget who's sponsoring him now, but you are able to see a good bit. And so anyway, I just wanted to let you guys know I'm trying to give resources so that no one needs to be like, ugh, I'm just sitting here because I worked so hard last night and I don't need this. I want everyone to be able to push forward from wherever you are, okay? And also this weekend, I want you to know you're supported in a few different ways, even if we don't get to tons of examples. Is that cool? Okay, so Khan videos, they're there to lead up to the practice and the Organic Chemistry Tutor. He has the typical examples. Khan probably goes to even some atypical ones, but the Organic Chemistry Tutor, I looked through this video, he has the typical ones that almost any calc book would give. Maybe with different numbers, but the typical problems he goes through and in really good detail. And for you guys to know, he's really, no, I wouldn't say he's similar to me. The way I teach is probably pretty similar to him. He's probably better than I. He knows a lot more than I do. I don't teach OChem, but we think and we process and we show work similarly, so hopefully that would feel really nice. Khan and I don't always. And anyway, I like him because he does explain things pretty similarly to how I do usually. Okay, so we are going to WebAssign. We're going to WebAssign, check out homework, then we're coming back really quickly at the key things from the quiz, the ones that are the most missed, because some of these, if you knew the term, you're good, but we do have, we have I think 3 that are our worst ones. They should have that. And then we can see if we can find that one that I think is technically incorrect, that we should put as an error in the quiz. And I'll go ahead and get that assigned for Josh and Mo to be able to do online. So we have all that, and then we're coming back to the Jamboard for 3.6. WebAssign, number 2 and number 5. WebAssign, number 2 and number 5. So number 2. Yes, you can see the answers. That's all well and good, but basically what you're doing for this one is you're ending in a graph that if you didn't have WebAssign, you would have to be coming up with on your own. Okay, yes, you always had calculators, but still. You were trying to see if you could get it on your own. They do ask for asymptotes, which would be like a pre-cal type thing. Actually, a few of these are pre-cal type things, right? So if we were to go ahead and grab the function, I mean, you can see the answers. If you want to be lame, you could just type it in the box and have it right. Like, honesty hour, right? True. But if you don't have work on your paper, I'm not going to give you full credit that you submit to Google Classroom. And the goal is, could you get it on your own? So let's see this function. This function is, I'm in the 3.5 Jamboard. That way, if anybody is looking at this video at a later time, you can go check out. Oh dear. Oh dear. I'm going to the end. Here we go. Let me go to right after where the homework slide. We did the tricky parts. I'll go right after the tricky parts. Okay. Guys, for almost every one of these problems where you're given an equation, don't you have to find a first and second derivative, right? So let's make sure that we can make the connections. I might not fill every single box, but let's review a couple things. A couple things like the pre-cal. A couple things like the pre-cal. Pre-cal is right here with intercepts. Pre-cal is right here with asymptotes, right? Be careful with the asymptotes. Are you getting web assign wrong just because you're not putting y equals or x equals? So y equals, this would be y you can fly. Y is, I know, fly, like it's the heights, but flying, just think like the spread of the wings, that's a horizontal line. Or you can think like on an xy axis. I'm trying to teach my Algebra 1 kids this. Get to the y-axis, it's y equals, get to the y-axis. Where's the 0? It's right here. If I was to show it, I would show it with a horizontal line. So y equals 0 with no x is that horizontal line. All of that to say, the same thing works for any x equals. I have a horizontal asymptote right there, which means these guys must be vertical asymptotes. I can't have a horizontal and a slant. It's a horizontal or a slant. So I have the horizontal, cool, no slant. These ones must be vertical asymptotes from my domain at the beginning. X can't equal 1 or negative 1. So I put down x equals 1, x equals negative 1 are the placements of the asymptotes. Okay, and intercepts, I think you try the x and y and there's only one. 0, 0 is both. So then when you come over here, and you're trying to find relative min, relative max, I'm getting out red because we need to look to the crits, and looking to the crits is looking to what derivative? Crits are found from which derivative? First derivative. Good. So look to f prime. F prime, you guys should have done a quotient rule. Bottom, d top, careful, put your parentheses, minus top, d bottom. Do you need to know your derivative rules? Yes. All over bottom squared. Sadly, in my two pieces of my numerator, bottom d top, top d bottom, there is no shared, well, I guess there's a shared GCF of 3, but no like x's to make life easier. So if I'm just doing some basic simplification, I would do some like distributing, then I would do some combining like terms. For instance, I have 3x squared and minus 6x squared, which is why I'm going to have a negative 3x squared. Minus 3, which I could simplify to be negative 3x squared plus 1. Ooh, interesting. For crits, this is good for all the homework. People that have done more, you know this as well. For crits, when I go to do my pitchfork, the bottom ones are going to be my domain issues, are going to be my vertical asymptotes and holes. No, vertical asymptotes. They weren't removable. Those can't factor away. The zeros of the denominator are the plus or minus 1. Those are VAs, so I ignore those. Those are not crits. The numerator, you're like, okay, cool, set that equal to 0. But if I set that equal to 0, well, hold on, numerator equal to 0. Would you guys divide both sides by negative 3? Would that be your start? Right? And when you divide by negative 3, isn't 0 divided by anything? Doesn't that just go away? And then what do I do next? Subtract the 1? But what happens when I get down to needing to take away my square root, and so I square root a negative number? Is that good or is that bad?
Absolutely.
Hence why it's DNE. There are no crits. If there are no crits, then there can't be any relative extrema. I don't even have to do a sign chart, even though I'm technically supposed to. I know there aren't any crits. So if I was to do like my first derivative sign chart, I wouldn't put any values other than my asymptotes. I would just put -1 and +1. I put little holes there just to remind myself, you're not a point, you're not a point. I could get in some big trouble if I forget that fact, that they're domain issues. But there are no crits. If there are no crits, DNE, I know there can't be any relative extrema. If I go to check my first derivative sign at things like, where is my first derivative? Here it is. At things like, take it step by step, -2, well, squared is a positive times a negative. That's squared, always a positive. So that's always a positive. That's always a positive. Everything is going to be negative. It's like that one we did 2 days ago, right? Where it's decreasing, decreasing, decreasing. If you guys checked out the graph already, I'm pretty sure, is it this one? Like that? I think it's something like that. But that's just me thinking ahead. But any questions on the first derivative, the quotient rule, the finding of the critical numbers? There's a lot of steps. If you don't understand why I'm doing something, we're in some trouble. If you're just making algebra mistakes, okay, we can work a little better, a little harder. We okay? Let me get my laser pointer real fast. So, quotient rule. To get my first derivative, simplify, simplify, simplify to pitchfork to get my critical numbers. Any imaginary numbers? Yeah, no, those won't show up on a real graph. Any domain issues? Nope, I totally ignore as well. Sign charts, I take my domain and I put that in the sign chart so I can still see what the graph is doing so I know how to make the match down below, but I will have no relative extrema. And I haven't done the second derivative yet. I'm going there next. Sarah.
Wait, did you explain the very bottom?
This guy?
Yeah.
Oh, I didn't talk about the y. Let me get my little green pen out for the asymptotes. Asymptotes, remember this guy is, if you go back to those hints, degree test are how we get the horizontal asymptotes. So in this guy, the bottom one. Exactly. Would be why that one's 0. And then the vertical asymptotes come from setting the bottom equal to 0. Yeah. And don't forget your y equals x equals, or else they'll get mad at you.
Oh, yeah.
Good. So then the only thing we're missing is the point of inflection. And the point of inflection, we would have to find the second derivative. Does that make sense? Second derivative, we have to do another quotient rule using this guy where we would have the bottom staying the same, d top, which might be easier for you guys to actually think of this guy when you're deriving, because derivative of the top, -6x, it's a little easier to see maybe there than there. Minus top. Now, this is a really, really, really helpful thing for you guys to see. When I go to do derivative of the bottom, it's a chain rule. I could FOIL it and take the derivative, but I have like a 4th degree polynomial. Chain rule. It's a function squared, a g of x squared, a u squared. We do the power rule first. Bring down the 2, make it a 1. But I'm not done until I look at that inner function and say, ooh, chain rule, time to multiply, think bunnies. Derivative of x squared minus 1 is a 2x. All over a squared is to the 4th degree. Now check it. This could be so disgusting to simplify. Can I get everybody's attention just real fast because we haven't done a lot of examples of these, just real fast. If you have an expression like this, and it could look many different ways, but very complicated that you need to simplify, okay? Very complicated that you need to simplify. Always find a big addition or big subtraction, or there might be multiple ones. I know it's messy, but there's a subtraction of a term right here, bottom D top, and a term right here, top D bottom. Are there any common factors? Don't go multiply. Look to factor. I call it the green pen trick because it's just a pre-cal trick. But when you see that there's an x squared minus 1 here, and there's an x squared minus 1 there. Sure, there are coefficients, whatever. I can deal with numbers. Getting a 4th degree or a 3rd degree is nasty because then factoring it, remember x cubed? Those are nasty. That took a lot of work in pre-calc. That's not something that's being expected to take a lot of time here in this class. There's a common factor. Take it out. Actually, let me show it a different way, which might make it make a little more sense. This is what I'm showing to my Algebra 1 kids, is I'm showing them factoring for the first time. X squared minus 1. Take it out. It's the GCF. When I take it out, I'm dividing, I'm undistributing, I'm undoing, I'm taking back what was, in a sense, multiplied in. So when I divide, I'm going to get rid of one of those, and I'm also dividing this guy. I'm getting rid of that. And then all of a sudden, I have one of these guys that can be totally reduced away. That just made everything so much simpler, in the sense of the degree of the polynomial in the numerator and all the work that we would have to do. Because then at this point, I can go ahead and like distribute and get a negative 6x. Oh, can I pull out an x too? Oh, bummer, man. I should have pulled out an x also. Yes, numbers, whatever. But once again, I'm fine with numbers. I can pull out an x also. Because then I can get rid of that guy. Get rid of that guy. That's even better. I was going to get an x cubed. I didn't want that. So negative 6x squared plus 6. Careful, careful, careful. 2 times 2 is 4. Negative 12, but with a negative will be plus 12. X squared. And then 4 times 3 is 12, and then plus 12. Double checking my math real fast. Bottom D top of the first derivative, where are you? There you are. Bottom D top, negative 6x minus top D bottom. Bring down the 2, keep it, and then times U prime, which is 2x. That's gone, that's gone. 2 times 2 is 4, and 3 is 12, and negative with the negative is a positive. 2 times 2 is 4, times 3 is 12, and negative times negative is a positive. Oh, third. Is my first derivative off? Bottom D top minus top D bottom. 3x squared minus 6x squared, negative 3x squared. Negative 3. Bottom D top. Minus top D bottom. Oh! Ha! Look at him, poor little guy. That guy went away, this guy didn't. That's what happens when you squish it all in. There he is. There he is. What I was noticing is I wasn't getting 0, but I just had forgotten my poor little x guy that was right there all along. So if I try to do a pitchfork, the pitchfork on the bottom will be that same exact issue that, Sarah, you were doing so well in 0 period. Domain issue, I actually don't need to worry about that. That's just the plus or minus 1 from the beginning. So those ones are vertical asymptotes. Ignore those, but up here in the top, I would have the x equals 0 or the 6x squared plus 18 equals 0. This guy is going to be imaginary. It's going to be a square root of a negative number. I'm doing the algebra in my head and thinking ahead. That's going to be a square root of a negative, but there's that point of inflection, or that possible inflection point. And to know that it's an actual inflection point, I would just need to go ahead and set up my little sign chart of throwing in the 0, which is a pip. and testing my concavity, including my vertical asymptotes that are not pips, but they still need to break up my number line. And then when you see that concavity change of, I believe it ends up being a negative, positive, negative, positive, I do not have points of inflection at either of these guys because remember, they are not actual points, they're open. So that sign change does not make it a point of inflection. Neither does that one. They also only gave you one box. This is my point of inflection because of the change. And if you found your intercept, you already knew if you plugged in 0. Trying to get, like, okay, we have 0, x is 0, cool, cool, cool. What's the y value? We would come back to the very beginning and say, okay, plug it in, but we already know that that's going to be 0 as well. And we're done. 0, 0. Whew. It's in the recording. It's in slide number 12. It's in slide number 12. Let me go ahead and pause the screen share for just a second if anyone's still getting some of that. You still have to make the match. But it's decreasing, concave down, then it's decreasing, concave up, decreasing, concave down with a point of inflection in between at 0, 0, and then decreasing, concave down with vertical asymptotes at -1, vertical asymptotes at +1, and a horizontal asymptote at 0. Should be what's going on. We can go double check real fast. Yep, perfect. There he is. Okay, we're going to number 5, but I paused the screen share so that you guys can get a couple more seconds on it if you want. There's that little graph I did at the top. Number 5. Okay, Sarah, you were saying on that one? Oh, Siri, I wasn't talking to you. I was talking to Sarah. Okay. Number 5. Oh, it has an E. But it's super similar in what it's asking, right? It's asking for asymptotes. It's asking for intercepts. Let me get a picture of this guy up. And if you guys want, we're going to slide number 13. Can I just check in with you guys? Just because it helps me make better decisions for future classes. How many of you guys are being productive? Give me a thumbs up. You're like, I'm being productive. Okay. Okay. Remember, it doesn't have to be with us as long as you're being productive and this is helpful. This time. Okay. Last question. That's not what I want. Undo. Okay, if you want in WebAssign, once again, we are going to number 5. Right, guys? That was the one? Number 5? Cool. Okay, let's check it out. So number 5 gives us the function. I'm going to green first. I'm going to pre-cal. Let me unshare. Sorry. Start sharing again and start sharing again. Boom, boom. There we go. Yes, I covered up the answers because I didn't want you to type it in the box. I'm giving some accountability. Intercepts and asymptotes. Intercepts and asymptotes. Intercepts, we would plug in x is 0 for... Oh, they say larger and smaller. Or we can do a couple different things. We'd either be setting y equal to 0, which would mean setting each of those little factors equal to 0. Find the multiplication and then identify what's on the right and left of the multiplication. If you take ln of 0, that one's impossible. The pre-cal says no. The behavior of ln says no. This one over here, though, I can say x equals 5. So right away, I do have a vertical asymptote. So that one will go down here, x equals 5. Horizontal asymptote. Ooh, remind me. We just went over this. Not what the answer is, but how do I do horizontal asymptotes again? Degree test. That's limits to infinity. Degree test, tops, bottoms. Ah, there's no bottom. So that means none, right? There's no bottom. Top wins. Oh, wait. Think about the pre-cal. This guy's a line. It's a line that's going down. A line that's going down, yeah, has no asymptote. It just goes forever up, forever down. But wait, what is this guy? He's a swoop, right? He's a swoop. E to the x is a swoop. If e to the x is a swoop, well, hold on. Swoop, there he is. E to the x's grow so strong to the right, but they decrease so fast to the left. E to the x, by nature of who he is, has a horizontal asymptote at y equals 0. Wait, what? Think of it. E to the x, if x is greater than 0, is going to be growing, growing, growing. But if x is a negative number, e to the 3x is actually, if I say that, like, y is that, oh, how can I put that? X is the negative of something positive. I'm just trying to show it to you. It'd be e to the negative 3y, which is 1 over e to the 3y. If his exponent is negative, there is a denominator. If his exponent is a negative number, there is a denominator. And he is it. Bottom wins on that side of the graph. Bottom wins, it levels off. Bottom doesn't win, it doesn't level off. But bottom wins, it does level off. Bummer. So there actually is a horizontal asymptote that some of you guys would have missed. Because E does level off when it has negative powers. Sarah?
Would it just be those two?
Should be. Let's double check. Because there's no other horizontal asymptote. Horizontal says oblique. Oh, no vertical asymptote? Oh, that's the 0. What am I doing? This is the intercept. I'm a dummy. Lo siento. I was doing zeros. Zeros are not vertical asymptotes. Yikes. So this describes my horizontal asymptote because of E. That's here to here. And then this was me finding zeros. Not of denominators. I was just finding zeros. Zeros are the same thing as y-intercepts. Nope, x-intercepts. When y equals 0. Sorry, kid. So it's just y equals 0 is that guy. But then for my x-intercepts, I should have x equals 0 is one of the intercepts.
It wouldn't be like the DNE because you said you couldn't do for that the 0 equals e to the 3.
So I have this one. My other one is a DNE, smaller and larger. How do you do that? Is there a y-intercept? Wait, we didn't do a y-intercept. Hold on, we didn't even check that one. So that was the x-intercept. What about the y-intercept? So the y-intercept would be, actually, no. You plug in 0, so it would be f of 0. So not y equals 0, but x equals 0, which would be e to the 0. Oh, careful. What's anything to the 0 power? So it'd be 1 times 5, which is 5. So I also have the point. This guy would be 5, 0, and this guy would be 0, 5. So which x is smaller? This one. It's a 0, and then the bigger x. So there aren't two x-intercepts, there's two different intercepts. One of them is the y-intercept, one of them is the x-intercept. Yeah, that was tricky how they asked that. Sorry, guys. They're just saying, whatever, find all the intercepts and then write them down. I'm like, okay. Good question. What rule do you need to be able to take derivatives of this guy? Yeah, right? Well, at least it's not a quotient rule. Wasn't quotient worse? So then f prime is equal to second. D first. That's a minus, sorry. D first. Hey, chain rule. Isn't that an e to the u? E to the u times u prime would give you 3 e to the 3x. Plus first d second. Derivative of 5 is 0 minus derivative of x is 1. 0 minus 1 is negative 1. But did you catch... Can I pause everyone again? Pause, eyes up, wherever you are. Pause, pause, pause. Did you catch... What did I have you look at last time I had you do this today? And why is my pen green?
The green pen.
Get him out of there. Get out that e to the 3x. Guys, this really comes in handy when you're doing like computational stuff with derivatives a lot. Pull them out of there. If you pull them out of there, you're going to have 5 minus x minus 1, which is the same thing as e to the 3x. 5 minus 1 is 4. 4 minus x. It really was easier than that quotient rule. Just got to get that product rule. I would say pitchfork, but the only denominator is 1, and that can never be 0, so I really just have to find the zeros. There are no DNEs. Sarah, go ahead.
And then what about the 3? For the first, so then 3.
Ooh, yikes! I fail. Forgot about him, like I forgot about the x. So it should be 15 minus 3x, yeah?
Yeah.
I don't know why I'm ignoring the poor little guys that are left behind. That's horrible. 3 times 5 would be 15 minus 3x. And then the minus 1, which would be 14. Great catch, kid. And then I set that equal to 0 because, like we already showed, we only need the zeros. There are no DNEs. But I thought about it. And like you guys saw up here, remember the e can never be 0, so the same thing. I can kind of just ignore that one and say, I want you. What is your 0? Well, 14 minus 3x equals 0 at, subtract the 14, divide the negative 3. My only crit is 14/3, which means I cannot have both. One of them is a DNE for my relative max, relative min. Well, maybe both of them are. There might be none, but at least one is a DNE. Which one? You gotta do your sign chart. So sign chart. There were no domain problems. That's cool. All I have to do is put in my crit. My crit is 14/3. Someone give me a mixed number so I can at least have some idea of what I'm doing. It's a little bit more than 3, 4, 5, 4, right? So I could plug in 0 to think of something down below it. I could plug in 100, think of something above it. Plugging in a 0 to my derivative. 14 minus 0 is a positive. E to the 0 is a 1. It's a positive, so positive times a positive. He's good. But if I plug in 100, 14 minus 300, it's a negative. And e to the 300 is a big positive. A negative times a positive is a negative. Who is this guy? Look at him. Who is he? Look at the plus and the minus. What does that mean? Oh, if it was a second derivative, but I'm in red. I'm not in the second. I'm in the first. So that means my function is not concave up. My function is, and then not concave down. My function is, who is that?
Oh, a critical number.
And, yeah, it's a critical number, and I can see that it has to be a max. So, my min is a none because I don't even have any other options. Whoa, where did the e to the 14th over 3 come from?
I don't know, I'm scared.
Don't be scared. Go back to Algebra 1 and say, if I know the x, how do I find the y? Plug it in. You had to come back up here and say, we need the y value, please. We know the 14/3. We needed the f of 14/3. Which meant we had to go back to pre-cal and say, oh, go get me the y. Getting the y would be e to the 3 times 14/3. Oh, the 3's go away. That's nice. Boop. It's e to the 14th. Times 5 minus 14/3. Any of you scared of fractions? Stop, you're okay. Make a nice little improper fraction. 5 over 1 times 3 over 3, wouldn't that be 15 over 3 minus 14 over 3 is 1 over 3. 15/3 minus 14/3 is 1/3. Who knew you were going to get good at fractions in calculus? Well, I don't know about good, but hopefully not worse. So 1/3 e to the 14th or e to the 14th over 3. So what have I not done? I can't do everything. I haven't done a second derivative. You just need to go blue. Use your green pen trick. Get that point of inflection. What point of inflection? At the end of class, I'll take away the gray box. How about that? At the end of class, I'll take away the gray box. All right, cool kids. What didn't I do? Let me actually do some color coding real fast. We did the intercepts. We went to the first derivative and figured out the critical numbers. That's not what I want. That was looking at the crits. What I'm missing is the point of inflection, and for the point of inflection, we just have to go one more derivative and say, what is f double prime? Which means we gotta do, oh, but that's so similar to what we did there. Yeah, so similar. So similar. Do a product rule. Second derivative, use your green pen trick to simplify, and then boom. Shakalaka, you got it. Okay, that's 2, that's 5, almost all of it. The gray box will be gone by the end of class. 3.6. Who is this guy? 3.6. Who is this guy? All right, take a breath, take a stretch. Give me a quick little, like a hand wave. If you would say you're at least halfway done with homework. Oh, that's it? WebAssign? Oh, okay. I thought all the time we took, maybe most of you could get halfway. So some of you just didn't come in with much done today. Because we did number 7, we did number 2, we did most of number 5. I thought that would get you at least like a halfway, but okay. So at least half the class is at least halfway. All right, we're going to section 3.6, so it's time for WebAssign to go away. Victor, what's up? Oh, you're stretching? Yeah. But don't worry, before we get too far into this, we're going to go look at that quiz, which is a little bit mentally, hopefully less taxing than the WebAssign questions, and then doing something new. And as I said, I'm just trying to introduce this section today. Then you have either Con or Organic Chemistry Tutor, or both, to kind of play with a few examples. Just try to get 4 examples done, 4 problems done. With Cons like need help, hints, etc. that you can use. The assignment says to attach work, so make sure that you're not just like, I don't even know how you would plug in numbers and try to get it right, but make sure you're attaching some work to get credit for the Con, and that you show me your score at the end of doing the 4 problems. You can always retake it if you want to. Remember, it just changes the numbers. But that's what's due by Monday at 3:30, but try 8 a.m. to at least have an attempt in. You might still want to like do it again or ask me a question. But try to have at least one attempt in. Let me pause, let me freeze. You guys are just getting notes set up, resting your brains a little bit if you haven't yet. Huh.
For the CalcAB,
Yeah.
is it like we're doing it like we do each one until we get it right, or is it like just the first 4 you're showing your work or whatever?
Do what you can. I don't, like for some people on these problems, doing them until you got all 4 right, it's going to take more time than I ever intend this assignment to take. So if you have 0 out of 4 or 1 out of 4, I'm not going to give you full credit, but if you can get like a 3 out of 4 or 4 out of 4, then you'll get full credit. And you can retake it. Let's say at least a 2 out of 4. Does that sound good? We'll say at least a 2 out of 4. So if it's a 2 or a 3 or a 4 out of 4, and you're like, okay, I have an idea of what's going on, that's perfect, that's what I mean. If you're like a 0 or a 1 out of 4 and you're like, I'm totally lost, watch as many videos as you can, then ask me questions in class. If that sounds manageable, I think that's fair. So I just really want you guys to get into it and try to get a feel for it, and then we'll work out the kinks with trickier problems on Monday. Okay? As you guys are, let me change the screen share back to the Jamboard. No, where are we? We're over here. Jamboard. There we go. Question. As you guys are writing notes and we're getting ready to go over the quiz real fast, give me a favorite animated either movie or TV show from your childhood, which could have even been like yesterday. Shout it out. First one I hear. Wait, what? Phineas and Ferb?
theme song. That song goes hard.
There you go, Mo. You can't miss out. I'm spilling myself this morning. Oh, that's lame.
Oh, yeah.
20 more seconds. Get what you can.
This part of the part.
This is not the mix it is. Never heard that.
It wasn't
That's
David.
what-
It's the theme song, the Phineas and Ferb.
No, that was the
I was excited. I was like,
Sorry. We want to do Perry the Platypus next time? Alright, so.
do it now.
No, we gotta have something that we've done. Alright, in your guys' quiz. Let's go check out those 3 that you missed the most in your quizzes. That's not the worst. That's not the worst. Ooh, those ones, 100%. That one wasn't great.
I don't remember it. I didn't remember it.
Okay, let's check out this one. This one wasn't great. I mean, it was better than some others, but. What does it mean if the derivative somewhere is 0? What does it mean if a derivative somewhere is 0? The first derivative, yeah, check it. Sorry, it's hard to see. The first derivative is 0, then this is defined to be a critical point, which is a possible relative extrema, but we don't know until we test. So if the first derivative is 0, all we know is that either we could say that there's a horizontal tangent line, or more broadly, it's a critical point. Okay, what's another one that we missed a lot of? Yeah, we have a few more 3. Oh, all right. G of x is pictured over what interval is G apparently increasing? Struggle bus. Over what interval is G apparently increasing?
Oh yeah, it was like 4 or something.
4 is here. 4 is like the point of inflection, right? So negative infinity to 4, 4 to infinity, doesn't that kind of say like everywhere but at the point of inflection? Negative infinity to 1, but 1 would be way down here. It's still going up at 1. 4 to infinity, but it's going up. Isn't it coming from going up? It is this one, the first one, because we don't usually do this in math. Like, we would just say negative infinity to infinity, but technically there is an instantaneous, a momentary, a split instant where it rested before continuing up, but proper notation, we would say negative infinity to infinity. So some of you guys missed that one because you're like, but I thought it was everywhere. That is the best answer. They just didn't put it in here. They're being really technical. How do we get out of here? No, I just want to... There we go. Ha ha ha. Pretty good. Ooh, not so great. Oh, why did everyone's accuracy go so far down with this problem? It's a graph. What's the big deal?
Shifted to the left.
Who is it? Guys, this is super serious. Like, this is one huge topic that we haven't covered and we're not covering today, but we need to before the AP exam. What is this the graph of? This is not pre-cal. That is not F. This is the second derivative's graph. Well, but that's exactly what I need all of you to see. Right?
Yes, sure.
Now, check it. Once again, I'm not teaching this today. I'm just kind of exposing you to it today and saying that this is something we have to work real hard on. Second derivative, I'm getting blue, right? This is a blue graph. Why am I marking the, ooh, check it. Aren't I marking the zeros of who? The zeros of
Double prime.
F double prime. Oh my goodness.
Oh.
Divorce yourself, like, ignore, no, this is a way of talking about, like, divorce your thinking, like, separate your thinking. I know this is a graph, but you have to transition over here and look at the words. What are the zeros of F double prime? of f, the zeros of f double prime, that's a pitchfork of f double prime. What are we finding when we do the pitchfork of f double prime?
Zeros and D and E.
Yes, and they're crits or pips? Pips. These are pips. If I was to do an f double prime sign chart, I would be putting my -5 and my -1. Now, how do I know the signs of f double prime? I ask myself, is it below it, meaning are the y values below, so the f double prime values would be negative numbers? Or are the values above, so the f double prime values, guys, this is f double prime. These little 5, 4, 3, those are f double prime values. So all of these little f double prime values are negative because they're negative numbers, they're negative values, or positive because they're positive values, or negative. If the f double prime graph crosses through its zeros, they are points of inflection because there's a change in the sign of the y or f double prime values. These guys are both points of inflection. Oh, I didn't even look at the question. Ugh, we should sue. But where is it concave up? Well, I answered that also, didn't I? Concave up is right here, from -5 to -1. Which is so weird if you're thinking pre-cal graph, but it's not a pre-cal graph. That is a calculus graph. It's a second derivative graph. Well, pre-cal, you would have no clue how to answer this question. You're like, what? It's down. The second derivative is down, but what does that mean about this other guy? And if you want to put some context, my physicsy people, the acceleration. This is a graph of acceleration. We're trying to think about position. Whew! All right, that was fun. We're going to have a few other people taking this quiz this weekend. I think that might be the last one I want to go over for right now. Except, wait, where's that one with the error? Did you guys not see the one with the error? I think you all didn't miss that one, which means it had to do with the second derivative equaling 0. Unless they didn't give you one. Did they not give you the second derivative equals 0? Ah! Number 5! Ah! You all got it right! And I think it's a bad question.
We all got it wrong.
You all got it right, but I think it's a bad question. That doesn't, I mean, you might have chosen the best of the bad answers. Like there is no good answer, so you choose the best of the worst. It is this. That's what they said the answer is. That's what they said the answer is. But why am I going to say there's an error in this question?
Because that's not what our
Lucas.
inflection point is.
It's only possible. This clue only tells me it's a possible inflection point. I have to go say that number 5 is an error. Now, did you guys choose the best of the wrong answers? Yes, you did. But I just needed you guys. That is not enough to say inflection point. We have to know the sign changes. So I'm going to say yes, and I'm going to say number 5.
Maybe.
All right, cool kids. Ready, set. The video that is in your Google Classroom, the organic chemistry tutor, I'm going to have him introduce my introduction of 3.6.
In this video, we're going to talk about optimization problems. The goal with these types of problems is that you're trying to optimize something. That is, you're trying to find the dimensions that will maximize the area of a plot of land, or that will minimize the amount of fencing required. Or if you're dealing with business type problems, you're trying to find a situation where you can achieve maximum profit or minimize costs. And so that's the goal of these type of problems. We're trying to find the optimal conditions to get the best results.
Did you just hear? At first, he said the goal of optimization is to optimize, and you're like, great. But what did he just say at the end? What did he just say at the end? You're trying to solve to get what types of results? Optimal. Oh, optimal is optimization, trying to find the best case scenario, which is sometimes the max profit and sometimes the min cost. Max and min, maximize, minimize. Guys, all we're doing is, we already know the calculus, how to find maximums and minimums. Weren't you doing that in tons of homework? Maximums, minimums, relative max, relative min. So what is this section going to have us do? Deal with words. However, sometimes the words are not that bad. Now, guys, there are a couple slides, and it will be a good idea for you to get those. I'm going to kind of talk through some of that next time, but we've already done a lot of critical numbers, sign chart review. I'm going to get the first example, which the organic chemistry guy, he starts off with these types of examples as well, and he does a few of them. But check it. In math, this is one of the most basic as far as the fewest words in a problem. Come on, guys, focus. Victor, Noah, here we go. In math, when it says find a number, I can call a number A, right? I can do that in math. I can name it a variable, whatever, it's an unknown. I can call an unknown A. Find a number in the closed interval. They give me kind of like a domain for that variable, such that, hey, is this something I can translate? Yes. If I'm trying to find if the number is as small as possible or the number is as large as possible, I'm trying to maximize or minimize the number itself, which is going to be A. I'm trying to maximize or minimize A. Oh no, wait a minute, the sum, my bad. It says the sum of the number is as large as possible or as big as possible. I'm trying to maximize or minimize the sum. But who is the sum? Well, I need to actually write something. S is the sum. The sum is addition of a number and its reciprocal. So what I need to do, calculus-wise, I need to get S prime, and I need to go looking for crits. And then I need to go ahead and, oh hey, all of this is normal stuff. As soon as you have an equation you can take a derivative of, now some of you are like, I don't like A. Okay, cool, whatever, it didn't have to be A. I mean, we can take derivatives of A just like X's, but we can make it X instead if that makes it nicer for you. We can call it X. Totally cool, no big deal. I can even say that's S of X. But as soon as I can make a formula, I can take it to the side and derive that formula and do a relative min, relative max, and I'm done. Well, unless I have an interval. Do you remember for absolute extrema? For absolute extrema, I'm actually supposed to do a table. This is going to be a review. Ugh. A table where I take my crits and my endpoints. You are dealing with open intervals for all of homework. If they give you a closed interval, you actually say, I'm only looking in between here and here for critical numbers. I'm going to try and find the largest and the smallest, but the question is, what are the crits? Well, to find the crits, we know we need to go to which derivative? Which derivative? Crits, relative extrema. First. So I need S prime. All right, cool kids. Come on. We're almost there. What's the derivative of X? 1. The derivative of, do you guys like to rewrite it like I do? And make it X to the negative 1? Cool. So then that's going to be negative X to the negative 2, otherwise known as 1 over X squared. Ooh, wait, would you use pre-cal to make your life a little bit simpler for the pitchfork? Would you get a common denominator? And see that this is X squared minus 1 all over X squared. So my crits would be X equals plus or minus 1 and 0. But what's the only thing that fits in between these two? 1. So all I would have to do is plug it in, going back to the original like you did for your ordered pairs of relative maximums and minimums, and say, what's 1/2 plus its reciprocal? What's 1 plus its reciprocal? What's 3/2 plus its reciprocal? And we're just trying to find the biggest versus the smallest. And so we do a little bit of pre-cal work in the sense that this is like 2.5, this is 2, and this is what, 1.5 plus 0.667, which would be 2.17. That's awkwardly in the middle. There's my biggest, there's my smallest. So I know that 1/2 gives me my biggest one, and 1 gives me my smallest one. This is what we're coming back to on Monday, but you guys get to, in your own timing this weekend, through con videos or through organic chemistry tutor video, get a little more examples, try out those 4 con problems all. Catch you guys on Monday. Bye guys.